All right, quadratic inequalities are pretty fun. You can do them just straight algebraically, where you're just writing down um, the algebraic expressions and you don't think about it geometrically. But it's really easier to think about geometrically, so that's what I'm going to do. I'm going to think of the left-hand side of the inequality as y equals that. I know it's a quadratic, so I'll multiply it out. But I also know where the zeros are, so when I sketch this, um, since x plus 2 was equal to 0, well, if I set the y value equal to 0, then either x plus 2 is 0 or x minus 3 is 0. That gives me x equals -2 and x equals +3. Those are my x-intercepts. I know the graph opens up because the coefficient of x squared is 1. It's positive. So I can do a quick sketch of this parabola. I don't actually care where the vertex is. What I care about is where the zeros are and whether it opens up or down. So I'll sketch that real quick. And then if you go back and look at the original inequality, what we're looking for now is the x values that make the y on this graph larger than 0. And so you can see where that happens on your graph. To the left of -2, the y values are positive. And to the right of x equals 3, the y values are positive. So those are our two pieces that will be in our solution. If you look at the x's between -2 and 3, those y values are 0. I mean, they're negative, so those x values aren't included in our solution. So now I basically have a number line drawn here in the graph, but I'll go ahead and write it out on a separate number line. I know I need to start at -2 and go out to the left. I'm not going to include -2 because I don't have greater than or equal to 0 in the original inequality. It's just greater than 0. And then I also have starting at 3 and going out to the right. And then an interval notation, that's -∞, comma, -2 with parentheses. And then remember, union combines two sets. And then open parentheses, 3 to infinity.